Hello and welcome to another saucy video where this time we will introduce to you why Citri-Fi works so well in pulpy sauces. You may say to yourself, what is a pulpy sauce? And officially, you don't usually hear people talking about pulpy sauces, but if you know anything about the French 5 mother sauces, they actually have a separate formal category carved out for tomato sauces. And that's because they're so different from any other type of sauce. But we decided that you can get that same pulpy texture in sauces using other vegetables than tomatoes and even fruits. So we just decided to use the terminology pulpy so that we include those as well. Pulpy sauces are made from chopped up vegetables and fruits. They have a unique texture, which is more puree-like. Citri-Fi itself is a dried form of pulp, after all. It contains all the fibers and pectin and has the same mouthfeel and body as pureed vegetables, but it does so in a concentrated, clean label, convenient ingredient form. So that you can picture all the possibilities, here's a starter list of sauces that benefit from increased pulpiness. Tomato sauces in their various forms are the obvious application, but think also of like other vegetable-rich sauces. These could be like pepper sauces or a chimichurri sauce, anything that's ground up vegetables. Remember also that Citri-Fi is good at binding water for stability and also binding oil. And since it can bind oil, it actually makes a very useful ingredient when making pulpy sauces that are intended to be used together with meat, like a spaghetti meat sauce, or perhaps they have oil added to them, like a sofrito sauce. The Citri-Fi will keep that oil from separating and becoming greasy. Okay, so looking deeper at some of the benefits that Citri-Fi provides, many are simply quality improvers, reducing syneresis, making the mouth feel better, having a clean flavor release, and freeze-thaw stability are a number of them. From a business standpoint, however, you might be interested in reducing the cost of an expensive ingredient. Let's say mango puree. Citri-Fi could be used to extend those purees 15% or more. And the last thing I want to mention is it says viscosity here. And to be sure, Citri-Fi does provide some viscosity, but it's not intended to be a high viscosity ingredient, as is. It only provides a mild increase compared to starches and gums. But there is a trick to increasing the viscosity, and I'm going to show you this later in the presentation. Most people don't like to think of their food like this, but food actually consists of cells. It's especially true if you're using foods made out of not too refined ingredients. Let's look at tomato, even though other fruits and vegetables are very similar. Tomato sauces are pulpy because they have all these macerated cells chopped up into fragments of cell walls. Citri-Fi is exactly the same concept, chopped up cell walls. One significant difference is that citrus plants produce much more pectin than other plant genuses. The pectin turns out to be very important for stability. Okay, so here's what a piece of a cell wall looks like up close. This could be a tomato, or Citri-Fi, or any other plant in general. This is how nature put it together. The large green fibers that you see in several layers are cellulose chains. Those cellulose chains are wrapped around other cellulose chains, and those chains are wrapped around other chains, and so on and so forth until the chains get quite big and kind of come together like a giant, strong rope. Weaving in and out of these fibers, you'll see the pectin is a more simple form. The pectin is considered soluble fiber, so it can dissolve in water and is used as a thickener, dissolved in water to thicken foods for a long time now. But naturally, in the plant, it's loosely connected to the rest of the cell wall. It tends to weave in and out of these big cellulose fibers. And this loosely connected pectin/fiber structure feels really good in your mouth and on your tongue because your tongue just recognizes it as food, much more so than any refined ingredient. Okay, let's look at some sauce examples. So there exists fancy processing equipment for making sauces, but there are a large number of sauces that are simply made just by mixing all the ingredients in a steam-jacketed pot or a kettle on a stove. It's heated in the pot and then packed off. So in this case, when you just do a simple mixing, you can use Citri-Fi and introduce some pulpiness. And you should be aware that you can choose different grades of Citri-Fi, as seen in this chart here, and it'll give you different types of pulpiness. Citri-Fi used this way will only contribute a mild amount of viscosity. If you'd like to have more viscosity, you have a couple options. Firstly, you could pair it up with starches or gums to get that viscosity boost. So use the Citri-Fi for all the other properties, but you get your viscosity through combining it in tandem with a gum or a starch. And FiberStar actually offers the 200 and 300 lines that do exactly that, if you're okay with having that on your label. But if you really want a nice clean label product that's thickened and thickened in a way that's compatible with pulpy sauces, it's good if you have the equipment, you can get a lot of viscosity from Citri-Fi simply by shearing it up with that equipment. Let me explain. Go back to our vegetable example. You start with a tomato in this case. It's made up of lots of cells. You know, industrially, they'll maybe make it into a paste or some sort of intermediate product. And that tends to kind of rip the cells apart. It's usually kind of a moderate shear process. But once you are able to apply higher shear that's high enough to break those strong ropes that I mentioned about the cellulose fibers, then you get more of a structure that looks like this. It's kind of a frayed entanglement structure. And this has been known for a while. You can use shear just the same way on Citri-Fi to get that powerful thickening effect. You can see from this picture that the Citri-Fi will only be kind of lightly thick and kind of this thick suspension here. That exact same concentration, when passed through a high shear homogenizer, can come out into a semi-solid paste if you shear it enough. So this is a great method for thickening in a clean label manner. And over here you'll see that the more powerful your shear equipment is, the higher viscosity you can go with this. So to summarize some of the benefits, Citri-Fi is a good alternative for adding richness to pulpy type sauces. And combining it with strong shear can turn Citri-Fi into a strong viscosifier. When shearing, you can either shear the Citri-Fi by itself in water to make a thick paste. Then you add that paste to the rest of your formula. Or, if you're making a pulpy sauce anyway, you can combine it with the other vegetable sources and shear the whole mixture together. Shearing the vegetables together with the Citri-Fi will boost the viscosity even more, but it will also smoothen out the sauce as it reduces the particle sizes. So only do this in parts of sauces that you're not trying to keep chunky or having, diced tomatoes in there or something like that. If you want to do something like that, you would shear the first phase and then add the chunkier parts at a later stage after shearing. Think about a time when you had eaten at a really good Italian restaurant and had a nice, rich, full-bodied sauce to go with your pasta. Now look at this picture of a relatively inexpensive marinara sauce that's sold at a popular U.S. national restaurant chain. Those two visions don't match up very well. In the picture, you can see how the starch-gum combination gives a longer, clumpy texture. So since you want this to be your classic pulpy marinara sauce, it would have been advisable to use Citri-Fi to extend the tomato pulp in this case, because it has that rich tomatoey mouthfeel as opposed to the long, kind of clumpy texture that you see here. Now, if you look at tomato sauce under a normal microscope, it's pretty boring. It just looks like a clear gel, nothing much to see. The trick is if you add a fluorescent dye to it, suddenly you realize that there's a lot of structure going on inside. And the dye, in this case, highlights the fibers. That's the green signal there. So those insoluble fibers, they drag across the tongue, and it's usually in the form of a big entangled mass of fibers and pectin. Kind of like a tumbleweed rolling around in the wind. It rolls right over your tongue and has that specific feel that your tongue is so used to. On the right, it just shows that when you add Citri-Fi, it has the exact same type of texture. It's adding more fibers to that fibrous mix. And that preserves the nice mouthfeel. Okay, so if you're going to thicken with starch, what's going on with starch thickening? Starch swells upon heating, and usually if you're using your starch correctly, you want it to cook up until it swells just to make the largest volume spheres as possible. It's kind of like blowing up a balloon. Most functionalized starches are designed to prevent the overcooking so that it doesn't burst. And they do that through various types of modifications. But nonetheless, these swollen balloons have a very different mouthfeel of their own. It doesn't quite match that texture of the vegetable fibers. We can show this also using the fluorescent microscopy again. In this case, we've overlaid it with the black spots, which is identifying where the starch is. The starches break up the long tangles of fibers into smaller portions, and it ruins that nice pulpy mouthfeel contribution. The bigger the starch granule, the more disruptive it is. So ideally, you want nice long-range entanglements of these fibers. And when you put the starch in between the fibers, it breaks up those long-range interactions and starts dominating the mouthfeel with its own spherical rolling type behavior. So what happens if you thicken pulpy sauces with gums? Well, gums are normally soluble in water, so they don't have all that natural particle feel on the tongue anyway. I like this graph by Marty Glicksman back in 1982, where he attempts to explain the relationship between rheology of the gum and mouthfeel. As it turns out, your tongue is quite a good rheometer. It can tell when the viscosity versus shear pattern, the pseudoplasticity, is acting unusual, just based on the shear forces in your mouth. So because of that, it's best to use this kind of thickening sparingly in a pulpy sauce system. Okay, let's look at some of these concepts in more applied terms. Tomato paste is usually classified in terms of its NTSS, which is really just a fancy name for bricks. It tells you how much soluble solids are in the sauce, and that's usually just due to natural sugars. By looking at the number, you have an idea about how much water has been removed from the paste as it has been processed in an evaporator. It doesn't really mean anything, though, when it comes to thickness. What really controls the thickness is the tiny amounts of tomato fiber and pectin that are in the product still. And also the condition of the pectin matters a lot. So this is why you only need low levels of Citri-Fi to get a thickening effect. Here we're going to look at adding Citri-Fi to a simple tomato sauce and then shearing it. So if we start with just the tomato sauce, which is the red line here, the control, we start the same amount of tomato solids and we shear, we see that the viscosity increases, gets thicker and thicker, and in this case it kind of peters out. And so this shear improvement is well known, but you can kind of see it kind of died out. Now if we take a look at what happens with just a tiny bit of Citri-Fi added, it's still relatively the same when you don't have any shear. So you're not really improving the viscosity much in the beginning, but it seems to take off quite a bit once you start shearing it higher and higher. And you could also, shear it longer and longer depending on what type of equipment you're using. But the bottom line is that you get this big benefit in viscosity at the end. It's almost as if the tomato sauce in the first case ran out of ammunition for the shear to work on, but when you have the Citri-Fi present, it has much more fiber to go to work on and make it even more thicker. So that's kind of interesting. How would you take advantage of this value? And there's two general ways you can use it. One is to try to keep the texture the same, thickness the same, but drive the cost out by using less tomato or whatever your puree happens to be. Or the other way is, if you're formulating from scratch especially, you can just use it in your formula to improve the quality. And we'll show examples of both in the next slide or two. So here's an example of a simple tomato sauce where we've added Citri-Fi on top and passed the sauce through a homogenizer. So take a look just visually at these two sauces. Just from looking at it, hopefully you'll see that a little bit of Citri-Fi improved the richness of the sauce. Just 0.2% took it from the left product to the right product. The Citri-Fi product has a deeper redness and a more visible thickness and richness associated with it. And the thickness is real. You can measure it on a Bostwick. In this case, that 0.2% took the Bostwick down by almost 2 centimeters, making it much thicker. And which of course was picked up by panelists in this blind descriptive analysis. And also it was driving preference as well. So that was if you wanted to improve your sauce, just the quality, the pulpiness, and the thickness, and so on. If you want to keep the thickness the same as your original sauce, but you want to make it cheaper, we found that you can probably reduce realistically about 15% of the paste using a small addition of Citri-Fi. So in the case of tomato, at current prices and volume, this corresponds to about 6 to 10% reduction of cost of the paste. Think also that the cost of those raw materials can vary quite a bit from year to year. So if you're using Citri-Fi to replace some of that paste, you have a little bit of insurance against unexpected ingredient costs. Okay, the last example is going to be a formulated barbecue sauce. Although many commercial barbecue sauces are thickened with modified starch, we wanted to see how much heartier the sauce would be by going back to the barbecue sauce's roots as a tomato sauce. So here's the formulations we looked at. The two products are identical except for the thickener. One was thickened with a clean label functional starch at a fairly high usage level, over 3%, whereas the other was Citri-Fi thickened at about 1.5%. The first thing we noticed upon tasting these sauces is the nice spicing of that formula really shines through when you're using the Citri-Fi. Some tasters said that we could even consider using less flavoring since it comes through so crisp and strong. In the bottom right corner, you can see what the Bostwicks came out for these two products. It was a pretty close match, considering we were guessing on the usage level a bit. But if you really want to get a dead-on match between your Citri-Fi sauce and some Bostwick standard, all you have to do is tweak the pressure on the homogenizer, for example, and back it down a little bit, and you can fine-tune that viscosity and get it exactly where you want, which is a lot easier than guessing on the usage level and doing lots of separate trials. Okay, so making a starch-based barbecue was kind of like a kettle cooking project. We simply heat it in a vessel and with light stirring until the starch cooks out properly. I want you to notice in the second picture that as we're heating it up, you see that there is oil coming to the surface. That oil was part of the spicing where we used an oil-based liquid smoke. So I just wanted you to see how that comes to the surface, because you won't see it with the Citri-Fi. So with the starch sample, we did not run it through the high shear device because that would just destroy the starch anyway. So per how the industry does it, we simply hot filled it into glass jars. In the case of the Citri-Fi, we also heated it in a vessel, but the heating is really more for hygiene purposes. Citri-Fi is actually very inert towards temperature. It doesn't thin out like most hydrocolloids. It doesn't need to be heated when you shear it, although you might get a little bit better performance when it's heated just because of the pectin. But by and large, it's fairly inert towards temperature. Notice in the second one how we didn't get those oil slicks on the top like we did with the starch. And then we fill it right out of the homogenizer. It goes in thin, comes out thick. In these videos, you can get an idea of the flow characteristics of the barbecue sauce as it's being hot filled into jars. The starch sample is a little bit more translucent and thinner at the high temperatures. And the Citri-Fi had a slight cloud to it and is very thick coming out of the homogenizer, even though it's hot. Wrapping it up here, in the video we hopefully demonstrated the value of being able to match to the unique texture of pulpy sauces, to boost the viscosity dramatically, and to emulsify, all with the clean label ingredient of Citri-Fi. We here at FiberStar would like to thank you for listening to this video. If you have any questions or would like assistance applying it to your own custom product, please reach out to any of these capable FiberStar staff. We'll be more than happy to assist. Also, check out our other videos that we have available on our FiberStar website or our FiberStar YouTube channel.